So good afternoon, all of you. So today we are going to discuss our last lecture on the oscillation. And basically today we just take a overlook of the superposition of the two or more than two SHM, and we will try to solve some PYQs that already comes in JEE and NEET. Okay, so this is the agenda of the today class. So let's start the class. As we already discussed in SHM, firstly we discuss the kinematics of SHM. If we take a quick closure, and in kinematics what we discuss is how velocity, acceleration and displacement that interrelated to each other, what is the governing equations, and what is the graphs with respect to time, with respect to position also. Then we discuss about what is the total energy of the particle that is performing SHM, and we also discuss what is the kinetic energy, potential energy at different point that we include between the two stream positions. Okay, and our next topic, that what is the concept of the time period and what is basic step involved that we can find out the time period of any oscillating body in simple harmonic motion. And in this case we already discussed about the time period of the spring mass system, how we can find out the time period of spring mass system, and what is the important result that we have to keep in our mind. Okay, so let's start the class. So in yesterday class we just discussed about the simple pendulum, that is the application of the angular SHM, and we already know that what is happening in the angular SHM. We can say that in the angular SHM a particle is performing to and fro motion just similar to linear SHM, but here one thing is different. Particle is in angular motion. So in this particular case, a hinge point is given by which particle is perform angular motion. So we know that what is the amplitude in the linear SHM, that is the distance between the mean position and stream position. This distance is known as the amplitude. In the similar manner, what is the angular amplitude? If you want to define angular amplitude here, so we can say that this is the distance between the main position and stream position, but in this case we interested that angular displacement, that is the angular distance or angular deviation. So we can say this theta naught, if this is the stream position, this is our angular amplitude, and in similar manner this is the angular amplitude in the another direction. Okay, I hope this is clear to you. And in the yesterday class we also derive an important relation for the simple pendulum, and we know that the time period of the simple pendulum is nothing but t equal to 2 pi root over L by G, where we have to keep in mind what is the L. L is the length of the bob from the point of suspension. So we can say that in this case this length L is nothing but the length of string. Okay, and G is, we can say that is the where the motion is performed. If we want to write down this formula in better way, so how we can write down this formula better? We can say, we also say that if we want to write down this formula, that if our simple pendulum is placed in such a place where apart from gravity some another force is also acting, then what force, what acceleration we have to take in here. Okay, what I am saying, just listen carefully. Suppose that if we place our simple pendulum in any accelerated system, then what about this G? Okay, in such type of case we just put the value of G effective. So we have to also understand this concept in mechanics also. So the upper time period can be written as 2 pi root over L upon G effective. Okay, what is the G effective? If we want to describe what is the G effective, So we can say that G effective is nothing but G effective is written as our G vector minus A vector and in magnitude. What is the magnitude of G vector, beta? That G effective can be written as G vector minus A vector. Okay. So let's we understand this concept with one example. Suppose that our pendulum is placed in an accelerating frame and say that this is our simple pendulum having mass m. And suppose that this frame is moving upward with the acceleration a. And in this case, if we give small oscillation, small disturbing force to our pendulum, then it will perform simple harmonic motion. We already know that. So in this case, if we want to write down what is the time period for simple pendulum when the frame is accelerating in upward direction. So beta, we have to just write down one thing. And what is the thing here, beta? We have to see here involve gravity is acting downward direction, acceleration is acting upward direction. So what is the net resultant of G minus A vector? How this formula is computed? This is, we can say, this is a trick by which we can remember, and by the process we know that if this is the accelerating frame, then we have to sit in this frame, and for sitting in that frame we have to apply a pseudo force, and pseudo force is always acting opposite to acceleration of the frame, that m into a. So we already say that G is also acting in downward direction and ma is also acting in downward direction. Then what is the G effective? That G plus A. I hope this is clear. That is G plus A. So we can say that G is acting in downward, acceleration is upward. So if acceleration is upward direction, then what is the direction of minus A? So we can say that if this is in upward direction, if we subtract here, so this will become minus A, and minus A, this will become plus A. I hope this is clear, because this is clear from here कि G is acting downward direction, acceleration of frame is upward direction, then angle between two vector is 180 degree. Then what is the resultant? We can say कि G minus A, this will become G plus A. So here, if we want to write down the time period, we simply say 2 pi root over L upon G effective, and this will become G plus A. I hope this is clear to you, what I convey with you. At the same time, suppose this is the case 1. If you want to write down the case 2, here the frame is accelerating in downward direction. Suppose this is the frame where the simple pendulum is placed, and in this case the frame is moving in downward direction with the acceleration A. Can anybody tell me what is the time period in this case? We can see that this is 2 pi root over L upon G effective. In this case, what is the value of G effective, beta? How we can find out the value of G effective? How we can find out the value of G effective? Anybody? Anybody can tell me how we can find out the value of G effective here? Come on, guys. Tell me. Okay. We know that, sir, here G vector is always in downward direction and A vector is also in downward direction. Then what about G minus A magnitude? So we can say that the G effective that can be written as see here. How we can write down here, beta? That is nothing but G vector and minus A vector. A is also acting in the same direction of G. This will equal to A vector. So this will equal to G minus A. If we put this value, this will become G minus A. So in such a manner, we can write down the things better. And if we consider another case, say this is the case 3. Suppose in the case 3, our pendulum is moving in rightward direction, having some acceleration A. Okay. So what will happening here, beta? If our pendulum is moving in rightward direction, length of string is L, mass of bob is M. Then what is the time period of the this pendulum? How we can find out? Just we have to think that is very easy, beta. And if we see the previous year paper, we can see ki how much helpful for us. So that is the simple concept and we can understand the concept very easily. If the pendulum is moving in a frame, which frame is moving? Suppose this is a cart and cart is moving in rightward direction with the acceleration A. So what is the basic procedure? Sir, whenever we see a body is placed in an accelerating frame, then how we can analyze the object beta? First of all, we have to sit in that frame and we have to compensate this by applying pseudo force. मुझे उस फ्रेम में बैठने के लिए कुछ कीमत चुकानी पड़ती है और वो कीमत क्या होती है बेटा? pseudo force लगाना पड़ता है. अरे क्या मैं सही बोल रहा हूँ? Yes या no? GNV Kolhapur. If everything is clear, to give me a thumbs up beta. Yes या no? Give me a thumbs up if anything is clear. आवाज आ रही है, सब कुछ क्लियर है, साउंड क्लियर है, स्क्रीन विजुअल है, तो जल्दी से एक थम्स अप कर दो. यस या नो? लेट्स मूव अहेड. व्हाट आई एम सेइंग हियर, सपोज our simple pendulum in the previous case and we already know time period equal to 2 pi root over L by G. Correct? 2 pi root over L by G. In this case, if our pendulum is placed in a cart and here cart is moving in rightward direction with the acceleration A, then how we can write down the our time period? बेटा मैंने ऐसे केस में सिर्फ एक सिंपल सा फंडा आपको एक्सप्लेन किया. Our time period is written in such type of case: T equal to 2 pi root over L divide over G effective. Whenever force of gravity is involved, write down the acceleration in the terms of G effective. तो नेक्स्ट मुद्दा ये आता है कि सर हाउ वी कैन राइट डाउन G effective here. तो सुनो here, कैसे बेटा कैसे करेंगे? लेट्स सी. मैंने बोला बेटा सुनो, अगर आपको इस कॉर्ट में बैठना होता तो आप एक कीमत चुकाते स्यूडो फोर्स लगा के. स्यूडो फोर्स इस बॉब पे किधर लगता बेटा? तो आप बोलते सर फ्रेम इज मूविंग इन राइटवर्ड डायरेक्शन, तो स्यूडो फोर्स इज एक्टिंग इन लेफ्टवर्ड डायरेक्शन, दैट इज MA. यस या नो बेटा? So if you want to see the FBD of the bob, one force mg is acting and one force that MA is acting and another is the tension is acting. Am I correct बेटा? Am I correct? Yes या no बेटा? अगर मैं आपसे एक सिंपल सी बात पूछूं कि बेटा व्हाट इज द नेट एक्सीलरेशन, तो आप बोलोगे सर वन इज MA and another is mg. So we can say that is the resultant of these two force and that is nothing but under root A square plus G square. So in this case, what is the value of G effective beta? We can say this will equal to nothing but G square plus A square over root. This is the first approach by which we can solve the problem. If we see the case 1, we already discussed case 1. We can say here lift is accelerating in upward direction. So where is the pseudo force is acting? In downward direction. One is the mg downward, another is the ma downward. Then what is the net acceleration? We can say g plus a. So here the net g effective is g plus a. If we consider the second case where lift is accelerating in downward with the acceleration a, so where is the pseudo force acting? Upward direction. What is the net force? One is mg, another is the ma. So what is the net acceleration? That is correspond to g effective g minus a, and that is the third case. I hope this is clear. And by applying this concept, you can solve any problem where the concept of g effective is involved. Yes or no, guys? Give me a thumbs up if everything is clear, so that we can move ahead. Yes or no? I hope this is clear to everyone. Okay beta, let's move ahead. Suppose this is the case beta. Here a physical pendulum is given. In the last class we discussed what is the physical pendulum. Any object which is hinged at some point except its center of mass Such type of system is known as the simple or compound pendulum. And how we can find out the time period? The same procedure that we follow in the case of simple pendulum. Okay, sir. Then how we can solve it? So what is the process? We just displace our body from equilibrium position, and here whenever we study angular SHM, then we have to displace the body a small angle theta in either direction. So we can say that beta, in this case, if we give a displacement of our body, suppose our body will displace like this and say this angle is theta. I hope this is clear. Yes or no, beta? Suppose if we, this is the original position of our body, and if we give a small angle theta displacement, so we can say here mg is acting downward direction, and mg cos theta, that is acting along the line of center of mass, and mg sin theta here, that create a torque about this point of suspension. I hope this is clear to everyone. What is distance L? This is the distance of center of mass from the point of suspension. और बेटा ये चीज खून में डाल लो बेटा, yes या no? What is L here? In the case of simple pendulum, L is nothing but distance of point of suspension from the center of mass. Okay, beta. If we want to write down the torque here, so we can say restoring torque, that can be written as negative direction of your displacement. You displace the body in anti-clockwise sense, but the torque of mg sin theta, that want to object in its original position. So this torque is opposite to displacement given by you. That's why we can consider negative sign. There is no problem with this. And what is the torque, beta? mg sin theta into distance, perpendicular distance, and this distance is the distance between center of mass to the point of suspension. Center of mass in the point of suspension, say this distance is L. What is the torque, beta? Torque is I into alpha. What I observe in our experience, most of the students committed mistake at this point. What is I? Everybody know I is moment of inertia, but here I is moment of inertia about which axis? About which axis? If you know the answer, you can comment in chat box. I is about which axis we have to take in here. Anybody can tell me? So what is our answer, beta? About hinge point. So we know that if this is a body, this is a rigid body, and this is the center of mass of the body, then how we can find out? How we can find out the moment of inertia in this case? In the rotation chapter, we already know that suppose if this is our rod, and this is the center of mass of the rod, and this is suppose hinge point at the corner of the rod. So we know that whenever we know the moment of inertia of the rigid body about its center of mass, say this is the IC. Okay, then how we can find out the moment of inertia? Any other axis, about any other axis which is parallel to center of mass, then we have to apply parallel axis theorem. Yes. So if we want to find out moment of inertia about this point, we can say that I can be written as I center of mass, and the distance between 2 points, that the point between the center of mass and the axis about which we have to find out the moment of inertia. And say if the distance is d, this will become md square. I hope this is clear to everyone. Okay. So in this manner, we can say that we know the moment of inertia about the center of mass is ICOM. If we want to calculate moment of inertia about the hinge point, this can be written as ICOM plus ML square, because the distance between the suspension point and the center of mass is L. I hope this is clear. Okay. So how we can write down here, beta? I can be written as, see here, alpha we can say that nothing but minus mgl sin theta divided over I, and for small displacement sin theta, that can be written as theta. So our alpha will equal to mgl upon I theta, And we know that this term is nothing but omega square. Omega that can be written as mgl upon I. What is omega beta? 2 pi upon time period. So what is, we can write down here mgl upon I. So we know the time period is nothing but 2 pi root over I upon mgl beta. This is very important formula beta. Why very important formula? Because a lot of question in previous year that asked in the this concept, what is the time period of a rigid body which is hinged at any point except its center of mass? What is I here beta? Any DNV can answer what is I here. So we simply say that I is the moment of inertia about the hinge point, about the point which is hinge at some given particular point. Okay. So here what we can say that this I is I hinge. Okay. I hinge. And what is L here beta? Distance of center of mass of body to the point of suspension. I hope this formula you can remember and always keep in your mind. Okay, beta. So let's solve a given problem on this concept. Suppose a uniform rod is given. Tell me answer. You have only 50 seconds. So after reading the problem, tell me correct answer. Suppose this rod is hinge at this point, and what is the length of rod? That is L. Mass of rod? That is M. Tell me what is the time period if we give a small angular displacement to this rod, and this rod will perform angular SHM. So for that angular SHM, what is the time period of this rod? Tell me answer in comment box. JNV KNR and JNV Kolhapur, tell me correct answer. How we can solve it? You have 50 seconds to give the answer. Please participate in question answering session. Okay, give me answer. Come on, guys. The same concept we already discussed. The object can take any shape. Here the uniform rod is given. We can say rod is rigid body. Yes, sir. So what is time period? How we can write down? We can say that T can be written as 2 pi root over I hinge. So what is the moment of inertia of rod about hinge point? What is the moment of inertia beta? If the rod is length L, so we can say if rod is uniform, then the center of mass is rod is lie at midpoint. And we know that this distance is become L by 2. And we already know the moment of inertia about the edge that can be written as ml square by 3. I hope this is clear to everyone. Yes or no? How this result will come? By applying parallelistic theorem. That ml square by 12 plus ml square by 4. If we solve, we will get answer. So I hinge we can write down here ml square upon 3 into mass of rod is mg. What is L here, beta? L is nothing but that is the distance of point of suspension from the center of mass. So here L is become L by 2. I hope this is clear. M is cancel out, L is cancel out, and this value is nothing but 2 pi root over 2L upon 3G. I hope this beautiful result you can derive here. Okay, beta. So let's move. If you understand this concept, on the same concept, the question is asked. Tell me correct answer. What is the correct answer? Come on. I am waiting for your result. What is the correct answer? Here it is given that find the time period of uniform disk for small angular oscillation. Come on, guys. What is the correct answer? Okay, beta. So let's solve. How we can solve, beta? We know the sir. If we give small displacement, this will take the shape something like this. And suppose initially center of mass is here, then center of mass will come at this point. So we can say there is a displacement theta is given. And we know the formula is nothing but T equal to 2 pi root I hinge divide over mgl. Where we have to keep in mind what is L? that is the distance of point of suspension from the center of mass. So for solving such type of question, we have basic idea of the rotation mechanics also. Otherwise, we can't give correct answer. How we can solve this problem better? We have to know what is I about hinge. So if we consider a disk beta and we know the what is the center of moment of inertia about the center of mass, and we can say this can be written as nothing but if the disk having mass m radius r, this can be written as ml square by 2. And if again if we want to find out the moment of inertia about this point, then we have to apply the parallel axis theorem. And we know that it is perpendicular. The two parallel axes are separated by a distance r, that is the radius of disk. So what is I about hinge? What is I about hinge? This is nothing but beta mr square plus mr square by 2. So we can say this can be written as 3 mr square by 2. So if we put this value here, and what is L here beta? This is the distance of center of mass from point of suspension, that is equivalent to r. So if we put this value here, we will get by 30 second beta answer in front of you 3 by 2 mr square divide over mg r. M cancel out, r cancel out, and we can say what is answer here beta? That 2 pi 3r divide over 2g. This is the time period. This is the time period. I hope you can understand this concept. Okay beta? If you can understand this concept, give me the correct answer of the next problem that is asked in the JEE 2012. Okay, so tell me correct answer. JNV Kolhapur, JNV KNR, JNV Bhavnagar. Can you tell me what is the correct answer of this problem? Again, this is the beautiful problem, and that is already asked in the previous JEE. How we can solve such type of problem beta? Take your time and comment in chat box. Come on. Okay. So first of all, we have to recognize the problem. The problem is asked that a ring is suspended from a point S. So this is the point of suspension. Okay. And this is the displacement from equilibrium. Okay. Initially ring. First of all, we have to mark such important point. What is given beta? Disk or ring? The disk. In place of disk, here ring is given. Okay. First of all, we have to solve the problem for the ring. Okay. And we have to find out the radius of ring where time period is given. So what is the formula for the time period in the case of physical pendulum? Because this is acting like as a physical pendulum. So we can say that this can be written as 2 pi root over I about hinge divide over MGL. Yes, ya no beta. Yes, ya no. Sir. In order to solve this time period, we have to find out first of all I hinge. So what is the I about hinge beta? We can say, sir, this is the ring and this is the center of mass. And what is the moment of inertia of ring about center of mass? Everybody know beta. Bachcha janta hai that mr square. So we know that ki beta ki this axis that is parallel to center of mass, and suppose this is the ring and this is the axis which is passing through edge. So how we can find out the moment of inertia about this point? We just apply the parallel axis theorem. So how we can write down this? Is is nothing but beta, that is I center of mass plus mr square. This value can be written as mr square plus mr square. Okay, so I hinge will become 2mr square. What is L here beta? That is equal to radius. Put this value in this equation and we will get correct answer. T 2 pi root over I hinge 2mr square divide over MGL. We know that M and M get cancel out, and in place of L we can put R. If we squaring both the side, this will equal to T square 4 pi square 2r square divide over g into r and r get cancel out, and g we can take pi square. Pi square is cancel out with g. So t is given that 2 seconds, this will equal to 4. 4 equal to 4 into 2 into r. What is this value beta? R equal to 1 by 2. So what is the correct answer beta? 0.5 meter. Option D is absolutely correct. So what we observe here is what is the concept behind such type of problem. If you know the concept and how we can apply the formula, we can definitely solve the problem within 50 seconds, 30 seconds. That depend upon your speed also. Okay. So what is our task beta? Whatever concept we learn, we just solve more and more problem. And the problem we will keep some standard books, and after that we have to solve our JEE and NEET PYQ questions. Okay, that will have to improve our accuracy and speed. The next concept beta, that what is the concept of the torsional pendulum. So what is the torsional pendulum beta? Suppose anybody having the twisting phenomena, if we twist some body and remove the force, body will want to attain its original position. Suppose if this is a disc, and if this disc is rotate somehow, and after the rotation, if we remove our external torque, this will regain. We can say that such type of phenomena that will happen, twisting resistance, twisting torque. And what observe beta, this is the example of the daily life when we use towel after taking bath, and if we twist the towel, applying the torque. So if we increase our twisting torque, then what we feel, then we have to apply some more torque in order to get more twist. Okay. So after ample amount of torque we have to apply, then we will get twist. So we can say this twist is known as the angle of twist, and this twist is nothing but that is proportional to the torque applied by S. So this torque is proportional to theta. Okay. In the same manner, where we can see our force is proportional to X in the case of spring. I hope you can relate both the concept. Here a constant is come into picture. Here the T tau is nothing but this is the torque beta. Don't confuse what is the torque. Actually, it is represented by tau in some standard book. We can, our convenience, we can say this is the torque. If we use a proportionality constant, that is the C here, and what is C? C is known as the torsional constant. What is C here beta? C is known as our torsional constant. So we have to know what is torsional constant, and sometimes it is also asked what is the unit. So we can find out unit also. So we know that this is the restoring torque, and this restoring torque can be written as I into alpha. Okay. So how we can write down that I into alpha is nothing but C into theta. Alpha can be written as C upon I into theta. After seeing this equation, the first thing came into our mind, sir, this is just similar to the condition of the angular SHM. And what is omega? We can write down here that C upon I. So we have to understand the meaning. C is the torsional constant, and I the moment of inertia of disk about the center of mass, because the disk is placed something like this. So what is time period? If you want to write down the time period, 2 pi root over I upon C. We just remember this formula, and such type of pendulum is known as the torsional pendulum. What is the time period? 2 pi root over I by C. Such type of question is asked. If we increase the moment of inertia of this by 4 times, then find out the increase in time period. So what we observe here, our time period is directly proportional root over moment of inertia. Okay, beta. So we have to mentally prepare such type of questions, and that is very easy. So in order to score good in any type of exam, we have to practice, and we have to keep all the concept in our mind. The next concept is the superposition of SHM. What will happen if two SHM that is applied a given particle? Suppose if a particle is performing SHM and if one force is applied in rightward direction, one force is again applied in rightward direction. Suppose we can say two SHM that is applied on a single particle, and the first particle, the particle having the SHM x1, that is the displacement of particle corresponding to first SHM, and this is the displacement of particle corresponding to the second SHM. So if we combine both SHM, then what is the net displacement of particle? So in such type of scenario, when more than two forces, more than two SHM, more than two waves, more than two fields are involved into picture, such type of concept is known as the superposition. Okay. So how we can find out the net displacement of SHM? That this can be written as x1 plus x2, and the equation can be written as a sin omega t plus phi. Suppose that the first particle having the equation a1 sin omega t. So what is the way how we can tackle superposition beta? We use a concept that is the wave phasor concept. We treat this particular equation like as a vector, where we consider that a1 is the magnitude of our vector and this omega t is known as the phasor. Actually, what we are want to convey with you beta, we just take a omega t reference line and whatever amplitude is given, we just draw a line that is say a1 here. So here this is the first amplitude a1 that correspond to first SHM. The second SHM that is imposed to a given particle having amplitude A2. But the direction is omega t plus theta. What is the meaning of plus here? If plus is present here, then we consider anti-clockwise angle from omega t. So this axis we choose that this axis is phasor axis omega t. And if we want to draw the phasor of this SHM, then we can say this is more than omega t by angle theta. And what is the amplitude? That is magnitude. Here we can say this is the magnitude A2 here. This is the A2. Because plus sign is present, then we have to turn anti-clockwise angle from the omega t. This is our A2. Okay. This is our initial point. This is our final point. And we know how two vector can be added. Join initial point to final point with the help of a straight line. So this is nothing but this is the amplitude of resultant SHM. Okay, I hope this is clear how we proceed this concept by using the vector phasor concept. What is phasor? Phasor is nothing but angular position. Okay, and we set a reference that omega t is horizontal, and if plus theta is present, then we have to move anti-clockwise. So in this manner, we apply the parallelogram vector type of law. So this is the A1, this is A2. If we break the component of A2, this will become A2 cos theta, A2 sin theta, and we can find out the A by using the parallelogram formula. This will equal to A1 plus A2 cos theta whole square. That base square plus perpendicular square. I hope this is clear. Okay. And if we solve this beta, we know what is the net resultant amplitude. That is the parallelogram vector formula. A1 square plus B2 square plus 2A1 A2 cos theta. What is theta here? Theta is the angle between that phase up to SHM. Okay. So here, if we want to write down the final equation of resultant SHM, this A value we can put here, and the final resultant of SHM, the amplitude is at angle phi with omega t. So this is the way that we can find out the superposition of two SHM. So what we have to learn here, how we can write down the resultant amplitude by applying the vector parallelogram formula, and what is angle phi. So phi is nothing but beta. We just apply the vector tan phi can be written as A2 sin theta divide over A1 plus A2 cos theta. On the same concept, we will see a question. The question is asked in the NEET beta. A displacement of a particle where simple harmonic motion is given at a naught a sin omega t plus b cos omega t. So here we have to find out the amplitude of the oscillation. How we can solve such type of problem? We know that this is constant here, and there are two type of SHM involved. This is the first and this is the second. So sin omega t, if we see that this is omega t, and this having the magnitude a. So what about cos omega t? How we can write down cos omega t in terms of sine? We can say this can be written as sin omega t plus 90 degree. Correct, beta? So what is magnitude of the second SHM? That is b, and which is 90 degree plus means anti-clockwise direction. So this is direction of the second SHM, which is 90 degree to the first one. This is initial point, this is final point, so this is our resultant magnitude, and this will equal to under root a square plus b square. Okay. And what is constant term? That constant amplitude a naught is already here. So what is the amplitude resultant? We can say here a naught plus under root a square plus b square. That option we can say D is correct here. Okay. So in this way we can solve. Let's move further with the next question. This question you have to solve by your own self. That is again very good question can be asked in the JEE 2019. Here we have to identify sine and cos is given here. So this is the superposition of SHM. Okay. So how we can deal the superposition of SHM? Anybody? Sir, we just find out, sir, the resultant amplitude. Okay. How we can find out the resultant amplitude? Sir, there are two ways. First of all, we have to write down the equation in the simple manner that 5 sin 3 pi t plus 5 root 3 cos 3 pi by t. It's a simple funda. Whatever I want to share with you, just try to convert both the trigonometric function in one term, either in sine, either in cos, either in sine, either in cos. Suppose if you want to convert all the term in sine, this is already in sine, so write down 5 sin 3 pi t. Anybody can tell me how we can write down the cos in terms of sine? So we can say that this can be written as sin 3 pi t plus 90 degree. Correct, beta? So what we observe here, this is our first SHM, this is our second SHM. What is amplitude of first SHM? Tell me, Kolhapur. That is 5. What is amplitude of the second SHM? That is 5 root 3. And which is 90 degree with the first SHM. Because this axis is nothing but that is omega t axis. Okay. And that is plus sign. Then we have to move anti-clockwise. We can say, oh my God, this is 5 root 3. What is resultant amplitude? Sir, join these two vectors. 5 square plus 5 root 3 square, this will equal to 10. So amplitude value aage beta, the amplitude will become 5 square plus 5 root 3 whole square, this will equal to 10. And what about the time period? We know the omega, both the omega is same. Time period is written as 2 pi upon omega. And in this way, we can write down the omega value 3 pi. This will equal to 2 by 3 seconds. Correct answer, option A is the correct. I hope this is clear to everyone. How we can solve the concept of superposition of two SHM. Okay, so what is the concept, beta? Just resolve the vector. Suppose 3 SHM is given, then how we can solve? First of all, we have to draw first SHM, then second, then third. Then take the horizontal component and vertical component, and this by using this concept you can solve it. Okay. Suppose if anybody asks to me what is the equation of the final SHM, we can say this is our resultant SHM. What is the angle made by the resultant SHM from omega t? Say this angle is phi. What is tan phi here, beta? tan phi can be written as 5 root 3 divided over 5. That is root 3. It means 60 degree. So what is our resultant SSM? X equal to, because equation is written in y, so we can say y equal to amplitude is nothing but 10 sine omega t plus 60. It means pi by 3. I hope this is clear. Okay. How we can write down the equation also? So this is the simple application of vector. The next is the damped oscillation. What is the damped oscillation? Whenever the non-conservative force is present. And in real life, what we observe beta, if we, after disturbing a simple pendulum, and suppose if we leave the simple pendulum, what we observe, after some time it will stop. It having not an finite energy of source, so that it will perform continuously oscillation. We know that because of the some energy dissipation factor involved in the environment, that's why it will stop oscillating after some period of time. Okay. Why this is happening? Because of the some air resistance, some viscous forces, some hinge resistance are involved. So in real life, there is no free vibration occur because of the some resistance. When this type of study come into picture, the such type of study where damping is involved, the physical meaning of damping is the friction. Okay. So what is the damped oscillation? When non-conservative force come into picture, such like as air resistance. And we know that this resistive force is always opposite to velocity. So here the opposite to velocity, that in this way we can find out the magnitude of the resistive force. And here a term B is come. What is B beta? B is known as damping coefficient. B is known as damping coefficient. Beta, very important. And from this year, this topic is also included in the JEE Advanced. Okay. So this topic in the JEE Mains, 1 or 2 questions that is asked in every session. So we have to remember the formula. What is the resistive force beta? That is minus B times V. V is the velocity at any displacement x. V is the coefficient of damping. Suppose our spring mass system, and if we displace spring mass system from the mean position such an amount of x, and at that time the block having the velocity v. So how we can write down the beta net force? One is the spring force kx, another is the damping force, that the viscous force, that is the friction force, that is also opposite to the velocity, and we know. So this is same direction. This is the same direction of kx. Kx and v acting in opposite direction, and because of the inertia of mass, the net force can be written as m into a. So this is equivalent to m into a. So if we solve this equation, put the value of acceleration, that is nothing but second derivative of x. Okay. What is the velocity? First derivative of x, and this is the x. Actually, beta, this is the second order differential equation, and that is not in our syllabus. Whenever we discuss in higher orders, in BTech, in the BSc, then we discuss what is the solution of the second order differential equation. But we have to know what is the solution of the second order differential equation. I hope this is clear. How we can form differential equation? By the dividing over mass and put the acceleration in the terms of second derivative. Okay. I hope this is clear. And if we solve the equation beta, we get the equation of displacement. This equation we have to keep in our mind. This Ax is equal to A naught e raised to power minus Bt upon 2m cos omega tt plus phi. This is the very important equation, and we have to learn this equation beta. Here in the either, when we learn the simple SHM, then equation is something like this: A sin omega t plus phi, either A cos omega t plus phi. But in this case, equation is something different. And what we observe, that this term is nothing but amplitude, and this amplitude is varying with time. Exponential decreasing function is involved. So this is the meaning of this. After some time, amplitude will become zero or oscillation will stop. Okay. Because of this, we can say acceleration for amplitude is also a function of time, and that is the exponential function. Okay, beta. What is omega d? That is known as the damped frequency. So here, how we can write down the damped frequency? That under root k by m minus b by 2m square. Okay. Here we can separate write down the equation of amplitude, that is a equal to a naught e raised to power minus bt upon 2m. So in this diagram, at t equal to 0, what we see here, amplitude is maximum. But after some time, the amplitude will continuously decreasing. At some time, it will become 0. Actually, this equation, this is the mixture of the sinusoidal function and the exponential function. That's why graph is something like this. This is not a pure exponential function. If it's the pure exponential function, then the graph is something like this. If it's pure sinusoidal function, then graph is something like this. But this is the mixture of these two functions. So graph is also combination of exponential and plus sinusoidal function. I hope this is clear. And we know that after some finite time, the amplitude will become 0. So that's why at some point of time, this will become 0. So what thing we have to keep in mind? One thing, exponential is time decreasing exponential function. And what is the damped frequency beta? That under root k by m minus b by 2m square. We have to keep in mind. Okay. Next, discuss about, because we know amplitude is continuously decreasing. It means the SHM is stop after some time. It will energy of particle will also equal to 0. Energy of SHM is also equal to 0. Why 0 beta? Because in the surrounding some dissipative force is involved, some non-conservative force is involved. So that will absorb energy from our system, so that our system continuously dissipate energy, and after some point of time, the energy will become also 0. Okay, I hope this is clear. So what about the energy? We know that the energy in SHM that can be written as half k square, that is constant. But unfortunately here, amplitude is time varying. And we already know amplitude is a naught e raised to power minus bt upon 2m. So if we squaring this side, what we will get? Our energy is something like this. This term is constant. Say that is E naught. So energy can be also written as E naught e raised to power minus bt upon 2m. How? Because we, by using the exponential property, this will equal to minus 2 bt upon 2m. 2 and 2 is cancel out. This is the equation of energy. One term we have to also keep in mind, what is critical damping beta? Critical damping means whenever the damped frequency will become 0, such type of case is known as the critical damping. And if we put omega d 0 here, this equation will equal a cos phi. And we know what is a naught e raised to power minus bt upon 2m and cos phi. So in this case, whenever critical damping is occur, we can say the graph is exponential decreasing for displacement also. Okay, beta. This is the question that is based on the damped oscillation. How we can solve this problem? We have to understand. How we can solve this problem? First of all, we have to listen and read the problem carefully. Bob of mass 100 gram perform damped oscillation. This is the key point. Because this is very easy to score in such type of topic because there is no variation. Because simple formula based question. And this is given that the spring constant is given, damping constant is also given. We have to find out time taken for A to become half of initial value. So amplitude will become half of its original value, then we have to find out that time. So this is very easy question because we know the relation of amplitude. What is the relation of amplitude beta? If we can say amplitude is a naught e raised to power minus bt upon 2m. Okay, sir. So amplitude will become half. So this will become A naught by 2, A naught e raised to power minus Bt upon 2m. This will cancel out and this will become 1 by 2 e raised to power minus Bt upon 2m. In order to find out the value of time, we have to take log for both the sides. And log base e, if we take both the sides, this will become log base e 1 by 2 and this will equal to minus Bt upon 2m. And we know that log base e that will equal to 1. And we know that beta this minus Bt upon 2m by using logarithmic property, this can be written as minus log 2. Minus is minus cancel out. And what is the value of time we can write down here beta? That 2m log 2 divide over b. This is the value of time. Put the value of mass and b, we will get answer. So what is answer here beta? Mass is given 100 gram because B is also given in the CGS unit. So there is no need to convert in kg. So we can say log 2 is nothing but that is 0.693. We have to know the value of log 2 beta in base E, that is 0.693. Okay, we have to keep in mind this value. What is B beta? That is 40. If we solve this, we will get answer. What is answer we will get here? We just solve this. Okay. So in the same concept, the next problem is asked time taken to energy to drop off half of initial value. How we can find out energy beta? For energy, we can write down energy can be written as E naught e raised to power minus Bt upon m. I hope this is clear. What is difference between these two formula here? Bt upon 2m, here only Bt upon m. So we just put the E equal to E naught by 2 and solve the problem. You will get answer. And in this case, this time will equal to 0.693. Okay. So I think you can solve this problem by your own self. Okay. And this is a homework problem for you guys. Here it is saying that the time period is 1 second. Okay. At certain time, its energy is 45 joule. Okay. After completing 15 oscillation, its energy will become 15 joule. What is the meaning of 15 oscillation? What is the time taken by Bob to complete one oscillation? One oscillation means it will perform complete to and fro for one cycle. So what is meaning of this beta? If time period is 1 second, it means it takes 1 second for completing one oscillation. If our particle will complete 15 oscillation, then what is time taken by particle? We can simply say 15 seconds. Okay. In this problem, we have to find out damping constant in second inverse. Not kilogram is given. It means it is asked per unit mass. Okay. So if we write down the formula of energy, how we can write down the formula beta? That E equal to E naught e raised to power minus Bt upon m. And say that initially the energy is 45 joule at certain time. Say that time is t equal to 0. So at t equal to 0, the energy is nothing but that is E equal to E naught. Okay. And after some time, that is 15 seconds. Say this is time 15 seconds. Our energy will become, this is initially 45 joule. This is the maximum energy. And after 15 seconds, this energy can be written as E naught e raised to power minus Bt upon m. I hope this is clear. Sir, what is E naught? Sir, E naught is 45 joule. What is E? It is given that energy will become 15 joule. So write down 15 here. E raised to power minus Pt upon m. This will become cancel out and we can solve here 1 by 3. Again, this can be written as E raised to power minus Bt upon m. If we taking log, so this will equal to log 1 by 3 equal to minus Bt upon m. Okay, sir. If we convert it into logarithmic property, in order to remove negative sign here, so this will equal to minus log and this will equal to minus Bt upon m. Minus minus cancel out. Where we have to find out damping constant. Beta always see unit. The unit of B is actually kg per second, but here second inverse is given. It means we have to consider mass 1. So what is value we have to find out here. If we by seeing the unit, the mass B can be written here. B can be written here. See here that m into log 3 divide over t, because mass is not given and it is asked for second inverse per unit mass, that can be want to ask that b by m can be written as log 3 upon t. What is the value of time beta? 15 seconds. We know that what is our answer, log 3 upon 15. Option D is the correct one. I hope you can understand the concept very clearly whatever I explained in the complete simple harmonic section, and we just completed our the 5 lectures where we complete and where I want to discuss all the basic concept with you guys, and I hope you enjoy the session whatever I discuss with you. Okay, and this session is helpful for you. Whatever series I will bring with you in the next coming 1 to 2 lecture, we just come with some basic mathematical tools, and that really help for strong your mathematics perspective in physics. So I hope this will help you at so that you can solve any type of advanced problem also. And for in today class there are some homework problem is also attached with you. So this can be, you can be get by PDF form, and you can contact with your center, so that in order to get the notes of our lecture whatever I discussed with you with them. Okay, the last concept, that is the what is the force oscillation. So force oscillation, in order to continue the motion of simple pendulum, because we know that if we not apply some external force, it will retard, and after some time its energy is dissipated continuously and its amplitude will become 0. So if we want to continue the motion, then we have to apply some external force, we have to apply some external agency work, we have to apply some external energy. On such type of oscillation where we want to calculate, we have to continue the motion, that is known as the force oscillation. What is the force oscillation? Oscillation of what is under the influence of external force. And in the force oscillation, if the frequency applied by external agent is equal to natural frequency of the object, if these two frequency will equal, that omega is equal to omega naught, this is very important situation, that is known as the resonance condition. Okay, so here we have to understand that this is a force that is applied by external agent. These two forces are already present in the damper system. Okay, so in the same manner we have to also solve the equation, that second order equation here, and we will get a result. Okay, but we don't discuss such type of result, we have to only keep in mind this formula. This amplitude can be written as F naught upon m. F naught is force amplitude, that is the maximum amplitude of force. ओमेगा is the driving frequency. Suppose अगर मैं इस बोतल को ऑक्सीलेट कराना चाहता हूं, तो मैं बाहर से एक फोर्स लगा रहा हूं. This is known as the driving frequency. जो मैं बाहर से फ्रीक्वेंसी दे रहा हूं, that is known as the driving frequency ओमेगा. इसलिए ओमेगा कैन बी रिटन एज फोर्स फ्रीक्वेंसी और ड्राइविंग फ्रीक्वेंसी. ओमेगा नॉट क्या है बेटा? द फ्रीक्वेंसी ऑफ डेड सिस्टम. ओके, व्हिच परफॉर्म अंडर द डैम कंडीशन. तो ये फार्मूला बेटा वेरी इंपॉर्टेंट फार्मूला, एफ नॉट अपॉन एम अंडर रूट ओमेगा स्क्वायर माइनस ओमेगा नॉट स्क्वायर होल स्क्वायर डिवाइड ओवर बी ओमेगा डिवाइड ओवर एम स्क्वायर. बिकॉज दैट डायरेक्ट फार्मूला कैन बी आस्क्ड. बेटा व्हाट इज द क्वेश्चन आस्क्ड फ्रॉम हियर? If B equal to 0, if damping is absent, then what is the amplitude? If we remove the B from here, so this equation will become F naught upon M under root omega square minus omega naught square whole square. So in the previous sub year, this type of question is asked, and we see one question on this concept. This is the question that is asked in 2004. A particle of mass m attached to a spring, natural frequency is omega naught. Okay. External force, that is function of time, that is the cos omega t applied to oscillator. The displacement of oscillator will be proportional to. So we know our displacement that can be written in terms of magnitude, that can be written as F naught divided over M, and this can be written as beta under root omega square omega naught square and b omega upon m whole square. So in this particular question, it is directly asked our displacement is proportional to. What is our correct answer? That we can write down nothing is mentioned and it is saying that natural angular frequency omega naught that is given here, and in particular question the examiner not discuss here the damping. It means we have to put the b equal to 0 because there is no discussion over the damping. If we put b equal to 0 here, then what is the amplitude beta? F naught divided over m, and this will equal to omega square minus omega naught square whole square. And we can say that p square and root is cancel out, and this will equal to omega square minus omega naught square. We can say the option B is the right one. Okay. So what we have to need to understand here, we have to just keep this formula in our mind. Okay. What will happen if we ignore the value of B? If B is very small, if damping coefficient is negligible, then we can put such type of result. One question also you can solve better directly. Tell me answer, what is the phase difference between the displacement and acceleration of particle in simple harmonic motion? What is the phase difference? Anybody beta? There is no need to solve such type of question beta. There is no need to solve. We know that it is displacement is x direction, then acceleration acting in minus x direction. We already know. Yes or no beta. So we can say that here beta, the answer is pi radian. Okay. So there is no need to solve this. So I hope the session is really helpful for you. Okay. So now I am going to quit the today class, and from tomorrow we just start our basic mathematical tools. So please join and enjoy the session. Okay, beta. Thank you so much.